Okay, so if we find out we have a function, if we look at the domain and every element in the domain goes to exactly y, then we can say we have a function and we have a notation for that that looks similar to this. Usually we have some sort of fancy f or some sort of fancy letter with x in parentheses, all right? And this is specifically saying that y is a function of x, all right? And the little fancy curly letter that is always in front of that x in parentheses is the name of the function. So we would, in this case, say f is the name of the function. All right, and most of you, if I spell that right, most of you have seen functions displayed as not only f of x, but g of x, all right, in which y is still a function of x, but this is the function g, that's the name of the function, and we could go through all of the letters of the alphabet and have different functions or different names for different functions. Don't let that scare you. It just means that usually if we look at two equations together and they're both functions, we like to call them by different names. We don't want to call them both f of x because they're different functions. So we say, okay, one's f, one's g, and if there's a third one, we'll call it h, all right? F is the name of the function, g is the name of the function, h is the name of the function. And just to show you what's going on again, we take some element from the domain, we call that x, all right? And then we send it through some sort of manipulative process where we change x into y. And that manipulation depends on the equation that we're presented, all right? If we have the equation y equals x plus 1, you're telling me, all right, Mr. Huffman, that's the equation of a line. In the last video, you said that all equations of lines are functions, so we could say this is f of x is equal to x plus 1. In which case, what's going on here? We're taking values of this function and we're manipulating them. How are we manipulating them? Well, we're adding 1. All right, and then it's going to spit out my value of y, which is f of x. All right, this add 1 to x, that's the name of the function. F is adding 1 to x, and that's what's going on there. So any function is doing this process. It's sending it through some sort of machine, and it's spitting out a y coordinate, taking elements from the domain, and it's finding elements in the range. And what we'd like to do for the remainder of this video is figure out what the domain is. What are all of the possible values that are in the set that satisfies this function? All right, so it's a process, and I'll record the process here on the board. Finding the domain of a function. So what you would find out in upper level math courses is that when it comes to theories and proving or disproving theories in mathematics, the easier route to take is to find stuff that doesn't work. All right. Let's assume this is true and find something that makes it not true. If we can't find anything that disproves it, then it must be true. And that's kind of the same process that we're going along here when we're finding the domain. We're going to start with everything. We're going to say the domain is every real number that we can think of. So that's the process we're going to start with, all real numbers. All right, so this is a large set. This is every single number you can think of from negative infinity to positive infinity. This includes -5, 0, 1. It includes pi. It includes the square root of 2. All of those are real numbers. Start with the domain being all real numbers. And then what we do is we start taking out things that don't work. All right, so we got to think of what does not work in algebra. What are things we cannot do in algebra? And there are two big things right off the top that we can't do in algebra. And number one is we cannot divide by 0. So what we want to do is remove values from this set of all real numbers that give or yield a 0 denominator. And you think, when can we get a 0 denominator? This is going to be any time that we see a function that is displayed as a fraction and our independent variable x is somewhere in that denominator. Anytime we see that that value, that x in the denominator of a function, that should tell us there may be values that we need to exclude from the domain. All right, so we can't divide by 0. What is the other thing we can't do in this class? We cannot take the square root of a negative number. There are some classes where you can do that. This is not one of them. All right, so we need to remove values that yield negative numbers beneath, I could say square root radicals, but it's actually any even rooted radical beneath even rooted. So square root, fourth root, sixth root, eighth root, so on and so forth, even rooted radicals. All right. So square root radical, fourth root radical, sixth root radical, so on and so forth down the line. All right. And that should be it. That should be at least up until this point. There will be some other stuff that we'll introduce later on. I hope you can hear me as I'm going to get my tea. There'll be other stuff that we introduce later in the course, but this is really all we have to worry about right now. Okay, so let's get to the examples. And I should probably do at least 4. And the first one is going to look like this. So example 1, we will do f of x is equal to 200, or let's do 2.5x minus 116. All right, so it may look a little bit intimidating, but it's not. This is actually just the equation of a line, where our slope is 2.5 and our y-intercept is negative 116. All right, what we're looking for is to go through that process that I've already erased. But remember, the first thing here was to start with all real numbers. So I'm going to start with the assumption that the domain is all real numbers. And in interval notation, if you guys recall interval notation, if you don't recall interval notation, this is something you should probably remediate. Maybe go to Google and Google interval notation, know how to do it. The interval notation says, okay, we're going to go from the low point to the high point, and we're going to go from negative infinity to positive infinity. And this means, these parentheses means we can't really touch infinity. We would use brackets if we wanted to touch a specific number, but we can't touch infinity. Then we start removing, right? We remove. So the first removal component is to say, all right, do we have any denominators here? Is there any way we can end up dividing by 0? No, not in this case. There is absolutely no way we can divide by 0 because we're not doing any division whatsoever here. All right. The next component, is there any way we can end up with taking the square root of a negative number? Well, that means that somewhere there would have to be a square root radical or a fourth root radical or a sixth root radical, and we don't see any radicals there. All right. So there was nothing to remove. There's nothing that would cause the world to explode here by division of 0 or the square root of a negative number. So there's nothing to remove. Therefore, the domain of this function is all real numbers, negative infinity, positive infinity. Let's look at example number 2. Let's look at g, and g of x is equal to 1 over, let's make this good. Let's do x squared minus 9. And again, I go with the process. I say, all right, I'm starting with a domain That is all real numbers. All right. And I say, all right, is there a scenario where we can get division by 0? Well, look, we have a fraction, and not only do we have a fraction, but the denominator of this fraction includes the variable x, all right? Includes values that we're going to plug in for x to get a y, all right? So is there any place where this phrase, is there any place where x squared minus 9 is equal to 0? All right, and if so, we need to remove them. They cannot be in the domain. Division by 0 is catastrophic, right? If so, remove them. And by solving this little equation for x, we would find out that x squared is equal to 9, and x would be equal to plus or minus 3. So when x is 3, or when x is negative 3, it gives us a 0 denominator. That means they need to be removed from the domain. So we remove x equals negative 3 and x equals 3. How does that affect our interval notation? Well, we still include everything that is less than negative 3. So we go from negative infinity to right up against negative 3, but not including negative 3. This means we're including negative 3.000001, but not negative 3. Any number between negative 3 and 3 is also okay. So this includes negative 2.99999, and this includes positive 2.99999, but not 3. And then we need to include any value that is greater than positive 3. And there we go. All right, so we started here. We remove values that would give us a 0 denominator. We're still not done. Do we need to remove anything else? Do we need to remove values that would give us a negative square root? A negative value beneath the square root. We don't see any square root radicals. We don't see any fourth root radicals. So there's nothing to remove there. We're done. This is our domain for example 2. All right. Again, if you stick with the process, you should be good. All right. What do we have? What do we start with? What do we need to remove because of things we can't do? All right, let's look at a couple more. Let's look at example 3. Well, let's do that. Example 3 will be h of x, the function h, and what it's going to do is 2x squared plus x minus pi all over the square root of let's do x minus 1. All right. Process. What's the first step in the process? Okay. Again, it's to start with all real numbers. So we're going to start with all real numbers. And then we need to remove anything that would give us a 0 denominator. All right, give us a 0 denominator. So anytime we need to remove any x such that, and guys, when you're working on this and you have your little scratch paper, you can write this on your scratch paper. I mean, feel free to write that down and tell yourself what you're doing. You don't have to store everything up here. If I need to write steps to tell myself what I'm doing, usually I have to do it because my head is all over the place. So, that's fine. Tell yourself what you're doing here. We need to remove any x such that the square root of x minus 1 is equal to 0. Any x that would give us a 0 denominator here. All right, you can solve this equation for x to find out what those x's are. Square both sides. If I square x minus 1, I'm going to get, or if I square the square root of x minus 1, I'm going to get that. And if I square 0, I'm going to get that. And then I add 1 to both sides and find out that when x is 1, we're going to get a 0 denominator. So we need to take it out. All right. What does it look like now when I remove 1? All right, that's the removal of 1. Am I done? Not quite, because we have a square root radical. Okay, we've already messed with it a little bit. So now I say, all right, I can't divide by, or excuse me, I cannot take the square root or the 4th root or the 6th root of a negative number. All right, so I need to remove any x such that I can't take the square root of a negative number, so I need to remove any x such that x minus 1 is negative, which means x minus 1 would be less than 0. That means negative. All right. And this means after I solve this inequality now, I add 1 to both sides. If you've forgotten your rules for solving inequalities, remember that multiplication and division by negative, switch the sign. That's something that you might want to remediate and look up on Google. But if I add 1 to both sides, this means I need to remove any x such that x is less than 1. Right? Anytime x is less than 1, we're going to get a negative square root, and we can't do that. All right? So we look at this, and we remove all of the x's that are less than 1. Well, guess what? That removes all of this. All right, that was in the domain until we have the square root thing, and now everything in there is gone. And what's left is 1 to infinity. That is your domain for example 3. All right, we'll do one more, and that'll be the end of this video. And I think I have 1 or 2 more videos for 2.2. There's just, there's a lot of things that are a little bit complicated that you need to spend a little bit more time explaining here. Let's see. The last example here, we'll call that example 4. So let's go back to f of x. And we'll say that we have the square root of x squared all over. Let's do the square root of, well, let's do this. Let's do x squared plus 2x plus 1. Let's try that. Hopefully this works okay. Usually when I try to think stuff up off the top of my head, it comes back to bite me, all right? Again, the process means we start with all real numbers. Start with all real numbers. Then exclude anything that gives us a 0 denominator. Exclude any x such that the x would give us a 0 denominator, such that x squared plus 2x plus 1 equals 0. All right. Is there any value of x that could make that 0? Well, let's use the quadratic equation, or let's see if we can factor that nicely. And we find out that x squared plus 2x plus 1, that should factor into x plus 1 times x plus 1. I hope. X squared 1, x plus x gives me 2x. That would be right. And this is the multiplication of two numbers together to equal 0. This would imply that x plus 1 is equal to 0 and x plus 1 is equal to 0. That would mean that x is equal to -1. So we need to exclude that value. All right. So our domain after that exclusion looks like this. And now we go to the final step. We need to take out any negative square, or any values of x that would give us a negative underneath that square root radical. All right. So let's look at that. Exclude. Now this will work out nicely for us. Exclude any x such that this would be negative. X squared is negative, is less than 0. All right. Well, just think about what's happening here. No matter what the value of x is, all right, no matter what we pick for x to plug into this, when we square it, it's either going to be 0 or it's going to be a positive number. If x is 0, then we have x squared, which is 0. All right. 0 is not less than 0. It is 0. So no need to exclude that. And any other number when we square it is going to be positive. All right. And a positive number is always greater than 0. So there will never be a case in this problem where we can think of an x that would give us, that when squaring it would give us a negative value. So there's nothing to exclude here. All right. This is not possible. So our domain is that number, or that value right there. All right. So this is something that, students tend to struggle with a little bit with the domain, but if you follow the process and you write things out for yourself, it can be a lot easier. I have a couple more videos on this section, and I believe the next one will deal with function evaluation. And you know what? That might be the last video for the section. So function evaluation and the difference quotient.